Hi, this is Rishikesh and Parth. We will be presenting word embeddings versus bag of word approach for sentiment analysis for the data science summer camp poster presentation. Uh, with the explosion of social media, more and more people are blogging and writing reviews about different places they visit. Yelp is one of the popular platforms where people post their ratings and write reviews. User generated reviews are usually inconsistent in terms of length, content, writing style, and usefulness because they are written by unprofessional writers. Also, they contain a mix of positive and negative emotions. Important information can be easily obscured unless users are willing to spend a great deal of time and effort on reading the reviews thoroughly. A common natural language processing technique is to generate bag of words and use that for analysis, but it does not account for the positive or negative sentiment of the user. So, we are using the word embedding approach to understand how neural networks can help us better identify the sentiments in the reviews. We are considering the 5-star ratings by user as parameter to measure the degree of positivity or negativity in the review, 1 being the most negative and 5 being the most positive review. Through this work, we hope to encourage more researchers to study and analyze the Yelp dataset. We will be investigating the Yelp Dataset Challenge Round 7, and also we'll be exploring two machine learning algorithms, SVM and long short term memory neural networks. We have divided our data entire project into three phases. The first is the data cleaning phase. The entire project has been done implemented in Python Jupyter notebooks. So we will be showcasing you the code while we describe it. So in the data cleaning process, we have converted the data from JSON file to flat format CSV. Then we have identified and removed features with null values. Uh, our data consisted of three different data tables. So we have used the inner join to create a master data set of 22,25,213 records. From this master dataset, we have created a random subset of 2,225 records. Uh, the next phase in our project is exploratory data analysis. In EDA, we are trying to find pertinent features for the next step, which is predictive analytics or machine learning task. When we visualized the distribution of star rating, we were initially surprised to see that it was skewed to the 4 and 5 star categories heavily. They consisted of around 80% of the distribution, whereas the 1, 2, and 3 star categories are only around 10 to 15% at most. This is confirmed by a separate analysis by Max Wolf on 1 and 5 star reviews, which showed that Yelp reviews have started to appear more optimistically biased as time passed. Our sample subset reflects this skewed distribution and uneven class distribution will even noteworthy further on our predictive analytics task. We use this information to set our baseline accuracy for algorithm evaluation to 40%, which is the percentage of 5-star ratings in the data. Next, we were curious about what kinds of words, including unigram, bigram, and trigrams, are characteristics of different star categories. So, we threw in some quick word cloud visualizations using the word cloud package. From these, we observe that the 5-star reviews contain many instances of great, good, and best. In contrast, the 1-star Yelp reviews use very little positive language. For example, horrible and worst. Sometimes we see sarcasm in form of words like wow and love used in 1-star rating. The 1-star reviews frequently contain warnings for potential customers, which promises that the author will never go back, and a strong impression that issues stem from conflicts with the front desk, such as at hotels. 5-star reviews love this place and can't wait to go back suggest a high positive feedback. Um, the lessons that we learned from these visualizations were that neural networks in form of word embeddings and long short-term memory neural networks can be used. Uh, to further analyze the Yelp reviews, we decided to see if they follow the famous Zipf's law and created the following two visualizations. Uh, from this plot, we can see that The Yelp dataset is actually following the Zipf's law and giving a straight line. This also indicates that TF-IDF vectorizer can be used for a better performance for finding the cutoffs. Through another visualizations, we see that the words such as the, and, to are repeated more prominently, and such words are the stop words which need to be removed.
Now, the data normalization part. For the data normalization, we removed the numbers in the strings, we converted all the text into lowercase, then we stamped the words to the root format, removed the punctuations, and then removed the stop words which don't help us in which don't help in the sentiment analysis task. For the data models, we first use the bag of words model. The bag of words model is commonly used in methods of document classification, where the occurrence of each word is used as a feature for training a classifier. For our experiment, for every review, we first created a sparse matrix from all the words within the review. Following this, we selected the top 1200 words from the matrix and vectorized them using count vectorizer from sklearn. The count vectorizer converts a collection of text documents to a matrix of token counts. This implementation produces a sparse representation of counts using SkyPipe sparse matrix. Thus, with the above setting, we created our bag of word feature matrix using the fit transform method, which was used further by modules like the SVM and the LSTM. Now the word embeddings. A word embedding is a parameterized function mapping words in some languages to a high dimensional vectors, perhaps 200 to 500 dimensions. Typically, the function is a lookup table, parameterized by a matrix. Word vectors is initialized to have random vectors for each word. It then learns to have meaningful vectors in order to perform some task. We are using the GenSim library for creating word embeddings. For the classifier algorithms, we have implemented the SVM and the LSTM. SVM is a large margin classifier popularly used for classification purposes. The LSTM. In a traditional recurrent neural network, during the gradient backpropagation phase, the gradient signal can end up being multiplied a large number of times by the weight matrix associated with the connections between the neurons of the recurrent hidden layer. This means that the magnitude of weights in the transition matrix can have a strong impact on the learning process. These issues are the main motivation behind the LSTM model, which remembers the previous state and also looks forward to update the current state. Now we can see the results of the LSTM model first. Using the bag of words approach, the LSTM training model gave us an accuracy of just 9.31 and the testing model gave us an accuracy of 10.50. Using the word embeddings approach, the LSTM training model gave us 11.90 accuracy and the testing dataset we got 8.67 accuracy. For the SVM, using the bag of words approach, we got 45.51 accuracy on the training set and a 42.31 accuracy on the testing data, which surpasses the baseline accuracy. Using the word embeddings, we got 40.31 accuracy on the training data and the same accuracy on testing data. One conclusion that we can what the conclusion we get from this is that overall SVM classifier appears to be a steady classifier. Now, given that we are using a very small data set, we expect a higher accuracy if we use larger data set. So the LSTM low accuracy we expect the LSTM accuracy to increase if we use a larger data set. Thank you.